Hi everyone, I hope you're doing well. So in this video, we're going to discuss Leetcode problem of the day, and this particular problem is sum of absolute differences in a sorted array, and this is going to be a medium level problem. So the problem says that we have been given an integer array sorted in non-decreasing order. So basically the array is sorted in ascending order. Right. Now we have to build and return an integer array result with the same size as nums, which is the origin array, and result of I should be equal to the summation of absolute differences between nums of I and all the other integers. So the question wants to say this. Let's say if we have a1, a2, a3 and a4, then at position 1 we want to have a1 minus a2 absolute difference plus a1 minus a3 absolute difference plus a1 minus a4 absolute difference. So this is the summation that I want to have at position 1, and I want to do this for all of the elements, right? So how can I essentially solve this particular problem? So the very first thing you would observe that we cannot take all the elements together in some way, right? Because some elements you see, let's say a1 minus a2. How do we mathematically expand this particular formula? We do something like this. If a1 is greater than or equals to a2, we write a1 minus a2. In other case, if a2 is greater than a1, then we write a2 minus a1. This is the mathematical expansion of this particular formula, right? But this means we want to segregate all of these different values. Some values are greater than a1 and some values are smaller than a1. So we would want some way to segregate these values. But to our surprise, the array that was given to us in the input was already sorted. That means all the values smaller than a1, a2 in this particular case will be present to the left of it, and all the values greater than a2 will be present to the right of it, right? So we don't need to worry about what values are greater and what values are smaller. The only thing we need to worry about now is how do I calculate this particular summation in one instant or O of one time without traversing through the array. So let's see, all of the values to the left of it will expand to a2 minus a1, right? Let us take a bigger example, a1, a2, a3, a4, a5, a6 and a7, right? Let's see, we are calculating for a4. So how do we do it? We would write a4 minus a1 plus a4 minus a2 plus a4 minus a3. We would write it like this for the left half, right? For the left half. So how can I reframe this particular expression? I would write 3 into a4 minus a1 plus a2 plus a3. So what is this 3? 3 is the number of elements present to the left of it, and this is the summation of those elements. So you see, I am able to derive the left half of the answer using O of one time and with the help of a constant expression. Similarly, for the right half, what will be the answer? It is going to be a5 minus a4 plus a6 minus a4 plus a7 minus a4. So you see, here a4 is negative, here a4 was positive. That is why we had to calculate this particular value in two different halves, right? Because the sign will get switched because the values have changed their magnitude. Now, how do I calculate this? This is going to be a5 plus a6 plus a7. This is the summation of all the values after it, minus 3 times a4. So 3 is basically the number of elements present after a4. So you see, if you have calculated the prefix and suffix sums, then you will be able to solve this whole problem in for each of the queries for each I in O of one time. So the overall time complexity will be O of n only, right? So what you need to do, you take all the elements to the left of it, calculate its prefix sums, right? And you take the number of elements, multiply by current element minus the prefix sum. This is going to be the left half. Similarly, for the right half, you take the suffix sum for all the elements after it minus number of elements after it multiplied by the current element, and when you add these both left and right, you will get the answer for the current A of I. So this would be the correct way to solve this particular problem. Let me show you my code. So what I have essentially done is, I have first of all taken an integer n to store the size of the nums array. Now I have created a prefix and suffix vector, right? So this is very basic thing, you must be already familiar with this particular technique. I have taken prefix of 0 as nums of 0 and prefix of n and suffix of n minus 1 as nums of n minus 1. Then for all the other values, I am calculating the prefix and suffix array. So prefix is basically adding the current value to the previous value, and suffix is basically adding the current value to the value after it, right? So I have done it in a single loop. You can also decide to use two different loops. It's completely fine. Now what I've done is I've created a vector answer n, and for each of the values from 0 to less than n, for the left side I'm first of all taking I into nums of I. So you see I'm taking this particular part I into nums of I. I will basically denote the number of elements after it, and if I is 0 I'm going to take prefix of I minus 1. So why I had to do this particular thing? Because my prefix and suffix array are in 0 based indexing. So if I take I minus 1 at index 0, this is going to be prefix of minus 1, which will give me out of bounds, right? And this is going to be wrong. So what I have to do is I have to check whether I is greater than 0, only then I am going to take prefix of I minus 1, otherwise I am going to take 0, right? Similarly, when I calculate for right, I will have to check whether I is less than n minus 1, then only I can take suffix of I plus 1, otherwise I will have to take 0, right? So I take this particular value and then I subtract nums of I into n minus I minus 1. So what is n minus I minus 1? For any index I, it is going to be the number of elements after it, right? So you can check this and you can also derive this particular value, and that this value is correct, right? So answer of I should be essentially equals to left plus right, and then at the end you can return your answer variable, answer vector, right? So let me submit this, and you can also see that this is also accepted. I have submitted again. This second solution is also accepted. So the solution is correct, that means, and I hope that you guys were able to understand this particular solution. If you guys did, then consider dropping a like on this video, and don't forget to share your thoughts in the comments, because your engagement with this video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye.